Welcome. Let's look at absolute value inequalities. Remember from the things that we did with equations with absolute value is that you have to clean it up before making two cases so that you have just the absolute value is equal to something. And then you make two cases where case A is whatever was in the absolute value. Normal, you just take the absolute value out. And in case B, you make the right side negative. So negative. So as an example, let's say this was x minus 3, and say it was 2x minus 3 plus 1 equals, say, 7. Well, we'd have to subtract the 1, and then I'm going to come over here to it. 2x minus 3 equals 6. Now we do divide by the 2, and we would get x minus 3 equals 3. And that would be the one that we would use. That's the first thing you do. That's clean it up. Clean it up. So you have just the absolute value by itself. Okay, and I'm going to write this here. Absolute value by itself. That's very important to do. Then you do the two cases. And so we're going to use this one. It's x minus 3 is equal to 3. And that's without the absolute value now. The absolute value bars simply, once you do the two cases, you don't need the absolute value bars anymore. In fact, you should not put them there. And then we have x minus 3 equals negative 3. Don't change the absolute value part. There is a way you could do it, and I'll tell you that you could decide to make it the negative x plus 3, change both signs, and then you don't change the sign over here on this side. That one stays the positive 3 like it is here. But that means you have to change two things instead of one. So it's like more concerning, more possibility of making errors that way. So don't do it that way. All right, change two things in the second case. And this is where now when you do the inequalities, this part is the same as an equation. But this part is new. You reverse the inequality sign. So let's take a look at a couple of examples of that. That's the best way to see it, is see it happen in examples. So here's one right now. These are and statements, which means they're less than statements, less than or equal. And I'll show you the difference in what it means to where they are. Well, first, this is the first problem, and I'm going to do case A, x plus 15 less than 12. In case B, x plus 15 less than or equal to 12. Notice it's because the absolute value side is by itself. There's nothing else over here. There's nothing to clean up. So we don't have to clean it up. We can just immediately go into case A and case B and take away the absolute value bars. So remember that. Take away the absolute value bars. Take away the absolute value bars. Now I'll finish this. Minus 15, minus 15. X is less than negative 3. And here I'll subtract 15. Oops, I forgot to put the minus here when I did that. In fact, let's come back for a minute because I wrote that too fast while I was talking. And remember this here. I didn't do it, so that's a good point to say I need to do it. I need to make the 12 a negative 12. I need to take this absolute value sign and I need to go the other way. So it's now a greater than. Okay, greater than. I'm going to subtract 15 from both of them. So I now have x is greater than negative 17. So when you have this, so actually I'm going to put this like circled in green or something to show very important two changes. Two changes. You want to memorize this. Memorize two changes. Very, very important for this. Now I'm going to continue. Now let's look at this on a number line. Although you don't have to do this, it would be a very, very smart thing to do. So I would guess that, say, 0's here, because I'm going to put like -3 here, and -17 is way down here. And for -3, x is less than -3, going all the way forever to -infinity. And this one's a greater than, so that means it's greater than 17 all the way out to positive infinity. And what you need to notice is that there's an area that's overlapped. So this overlapped area here, this is what the answer is. When you have an overlapped area, now we're going to put x in between these, and that means that x is less than the -3 and greater than the -17. So I'm going to put that in answer form, which means in brackets. It means the solution set is that x is greater than the -17 and less than -3. If it's overlapped, it must be put together. So in other words, this is correct. If you do this, less than -3 and x greater than -17, that's wrong. The numbers might be right, but the way you're writing it is not right. So I insist that it be done this way. So instead of the green, I should do that with okay. I should do that with yellow because I've always been using yellow for the answers. So let me rewrite it with yellow. So it's the solution set where x is greater than -17 and less than -3. Now I'll use the yellow. All right, now having done that, let's take a look at another one. This is one where now we have to first clean it up. Clean it up. Then we will do the two changes, the two cases and the two changes. So to clean it up, I'm going to add 20 to both sides. So I get 3, absolute value x plus 2 is less than or equal to 20, take away 8 is 12. Notice that was a negative, but because we have to clean it up first, that means that it still can be possibly an answer. And with greater thans and less than, that is an answer. Remember that there was a little thing, let's quickly review this here, that if we had an absolute value and it was equal to a negative number, like absolute value of x plus minus, didn't matter what it was, is equal to a -4, it can't be done. You can't do that. That's a no solution. Not true for inequalities. It could actually be true, but we're not dealing with those right now. So just remember, you don't apply that anymore for these. You clean it all up first. We could do it, but I'm not going to put one of those kinds of problems for you. Less than or equal to 4. Okay, now we can do case A, which is x plus 2 is less than or equal to 4. And case B, and this time I'm definitely going to remember to do the changing or the reverse of the inequality sign and make that negative. So I did the two things that I needed to do, two changes. 1 and 2. Okay, now I need to solve them. Let's subtract 2. So x is less than or equal to 2. Subtract 2, x is greater than or equal to -6. And when I put them on a quick simple number line, say here's 2 and here's -6, greater than is that way, less than is that way, and they're both filled in circles. And that means my x is in between them. So the solution set is that -6 is less than or equal to x, which is less than or equal to 2. There. So although you don't have to do the number line, it would be really smart to do the number line. Really, really smart to do the number line. Okay. So in these cases, this is an and it's a less than. When we have greater than, that means that they are or statements. And that means the graph of them will be like going opposite ways. And it's either these are the answer or these can be the answer. Okay, as opposed to it has to be overlapped. So let's go ahead and do this, and the rules still apply, the same rules. Case A and case B, x plus 15 now less than, and change the 12 to a negative. Same rules. Same changes. I'll call it. That should be a better B here. Okay, now I'm going to solve it. Minus 15, x is greater than negative 3. Minus 15, x is less than negative 27. So when I do this, here's negative 3. Here's negative 27. So here it's larger than that, and here it's less than that. So in this case, we do say that x is less than negative 27, or x greater than negative 3. Must write this. Well, first I will do that. And then let's make a note there that you have to write the or for the or statements. The and you don't have to because you're showing it in between them. Okay. You must write or. Very good. Got that. Now this other one ends up being the same type of thing as above here, where we have to clean it up first. So I'm going to add the 20 and x plus 2 greater than or equal to, whoops, I put 12, 20 when I know, now it's 12. And then I'll divide by the 3. Now that I have that, now I can do the two cases. A, x plus 2 is greater than or equal to 4, and B, x plus 2 is less than or equal to negative 4. Two changes. So I'll continue these, and we get some answers very similar to the last problem, the one just above it. X less than or equal to negative 6, except now on the number line, we're talking greater than or equal to 2 and less than or equal to the negative 6. Whereas up here, it was overlapped. And here it doesn't overlap. They go in opposite ways. So here we will write x is less than or equal to negative 6, or x is greater than or equal to 2. And then let me point out something here on this. You have to follow the number line direction. So for instance, if we take either one of these, okay, let's take this one down here. Incorrect to do x greater than negative 3 or x less than negative 27. That's because then we're going the wrong way in the order. These are smaller, and these are larger. And we don't go from larger to smaller, we go from smaller to larger. Just like up here, okay? Let's take this one. Let's say somebody did this. 2 greater than equal to x, which is greater than or equal to negative 6. And see, the negative 6's should be ahead of the negative 2's. So that would be wrong. So be very careful to have the order going from left to right, smallest to largest. Okay. So this shows you the basic examples here of doing an and or an or statement. Okay? And when they are overlapping or when they're not overlapping, going the opposite ways. So let's look at a couple of quick practice ones. These are good ones right here for you to pause the video, come back when you're done, and then pick it up, and I will be doing these. Okay, welcome back. Let's add 2 less than 10. Dividing by the 5 gives me absolute value x plus 1 less than 2. So here is my true absolute value, which means now I can do case A, x plus 1 less than 2, without the absolute value bars. Case B, x plus 1 now greater than negative 2. 2 changes. You don't have to write 2 changes, you just have to do them. Okay, so I'll subtract 1 for both of these. Here I get that x is less than 1 and x is greater than negative 3. So when I put a 1 here and a negative 3 here, less than 1 are all these, greater than negative 3 are all these, which means we have an overlapping area. So x is between these. So I have negative 3 is less than x, which is less than 1. And let's put that in the answer brackets. Okay, so that's one of these. This one was an and statement because it's an overlap. That makes it an and when it has the overlap. On the other one here now, let's do this one. I'm going to add 8. You can guess that since the first one was an overlapping, this one will be not be. It will be the opposite. It will be an or statement, but let's find out for sure. Okay, we're 38 here. And I'm going to divide both sides by the 2. So I have 4x minus 1 greater than 19. Now, if that had been a negative 2, I'd make a negative 19 there now and greater than that, but I don't need to here. Let's go ahead now and do case A without the absolute value bars, and case B with the 2 changes, less than and negative 19. Star, because yes, that's important, that I did the 2 changes. Okay, I'm going to add 1. So 4x is less than 20. Let's divide by the 4. X is greater than 5. Okay, let me think of my numbers here. 38, 40, 19. I think I've got them right. Adding 1 gives me 20. Divided by 4 gives me 5. Good. Okay, let's do plus 1. 4x is less than negative 18, it looks like. Okay. So now that gives me, when I divide by 4, x is less than a negative. 4 goes in 18 4 times with 1/2 left over, which I'll do is a 4.5. Okay. So now let's look at it on a number line. 5 is in the positives, negative 4.5 is in the negatives. This one's saying greater than 5, less than that, not equal to. Notice it's not equal to, so that means we have to put it that way, put it without the filled in dots. So x is less than the negative 4.5, and here we'll say that x is greater than 5. So we do the statement with the solution set brackets. We do x less than negative 4.5 or x is greater than 5. There. So it has the or statement in it. This one doesn't have an or statement, but this one's overlapped in order small to large. Okay, we have it in the right order there. And the same thing with this, in order from small to large too, on the other side here. So what we've seen here, okay, is to follow the same things for inequalities of cleaning it up and making two cases. And sometimes you get it where there's an overlapped area, and sometimes you get it where they're going in opposite directions, and then you use the word or. And these practice ones help to illustrate that too. I hope this helps. Thank you for watching.